TruTopsCell is structured in the way that Windows programs are. At the top we have the message bar, the information bar. We can import different CAD drawings and data. We have different interfaces here that we can use in order to read in the part. Then we have more menus here we can click through. And we will start here by preparing the workpiece. It's disconnected from the machine in the beginning. It's completely free. Here we have the tools, the different commands, and we also have our tooltips that we can use just to read up what the different functions actually do, what they can be used for. Then we have some additional information on the commands here, for example, in writing, and then we also have the symbols, and then we have some more possibilities in an option window on the bottom left, where you can carry out a lot of settings. So we will prepare the outer contour first. We have selected one surface. A tooltip opens, so we can select all surfaces and complete it. And then you can see we get all of the curves, all of the contour around the part. Theoretically speaking, we could start immediately, but there are some possibilities where we can carry out changes. So we can move a start point, for example, or we also have another possibility if the cutting direction should be different, the vectors should be different. So the position of the head, we can use this menu here to use the move tool in order to change the position of the vectors, and then you can see the vectors have been aligned differently. So once we have finished all of this, we can start loading the machine. On the bottom left here we have a job or task window that tells us the next job, the next task. That means we need to load the machine and create a program. We have a whole host of machines available here. We are using the TruLaserCell SW48 here, the L59, so we can select it. We can create the different settings. We can set a different table, or within this parameter tab, we can define different approaches or withdrawals. Here, we can also select our very own technology table. So these values have all been set, but we can change them at any time to fulfill the needs and requirements. So first of all, we position the part in the best way possible in the work area, so we have a good start. Then we have the move tool, which is already active, and you can see we can shift the work piece and move it so it has the perfect position. Before we start programming, I will show you how to create a fixture quickly and very easily. The workpiece, you have a top view here, and we have predefined possibilities to add vertical supports here in the example, or horizontal supports, or supports that go right through the workpiece at an angle. Once we have created that, what is special about this software is that we do not have any touching surfaces to begin with. We do this later, so we can use point-to-point functions in order to calculate the surfaces that actually touch the part. So we know where the part is positioned, where the part is touching the fixture, so we don't have too many touching surfaces. We can create these support surfaces or touch points, so it's not possible where there are holes, but we can select the touch points here and there. So once we have done this, we have a conclusion, a concluding function with a menu where we can perform some more settings, and now the fixture is automatically created. Inserts and cutouts are already created that make the fixture lightweight and make sure that the exhaust system, the extraction system works. And here we have the numbering for the assembly, the sequence for this fixture is also an assembly sequence, so a step-by-step instruction on how to assemble the fixture. So seeing we have an entire CAD system available, we can also modify the drawing. For example, we can create an extra cutout in the base plate for whatever reason you might need this. So we can create another hole here. So far, so good. Once we have done all this, we can go back to the programming. The fixture is automatically transferred. And so now we are in a programming mode. We start by setting the 0 point. This is only one of many ways of doing it. So we set the 0 point on the crosshair of the fixture. And now we can start with the programming for the processing. So we can manually set the sequence step by step on our own, or we can use the automatic setting with this tip. And this automatic sequence is the sequence tool that we can use by resorting the steps here with this tool. So we will calculate this. It will take a small while, and then we will receive an optimized NC program. So we don't have any collisions, if this is at all possible, and optimization is already carried out within the program. This is all done automatically, so you can see everything is blue. So this is a good sign in this view, because this means absolutely no crashes, no collisions. But of course, if you want to, you can also manually change different points, optimize them. For example, here we can improve the transition, lift it slightly, or here at the outer contour, we might be able to modify something if that is necessary. So here we have the move tool. We are moving the contour to the outside, and you can see it has been extended. If you want to, you can also create a copy of the program, just in case you want to take a look at the original version when you started. And if you change something now, you can see here in the background we have black vectors, black geometries. That's the original program, the first program. This shows us the situation we had before, and the blue version is the new version, the up-to-date version, the current version. So you can also change the program differently. You can use the editor on the bottom left, for example, so you can enter information directly into the editor, so some information that you might require. Oops, that was the manual. So we close the editor again. So you can directly work in the editor. And you can also use the Move tool in order to change the B and C settings. So you can change the B axis, the position of the B axis. You can enter the angle, and you can see if you make a mistake, if you go too far, collisions are highlighted in red. So of course you can always see crashes and collisions. Then you can export the program directly to the machine or onto an external drive, and you can also re-export it, reload it back to the programming system once modifications have been carried out at the machine. So now the program is finished, we could go to the machine.